would I do with an island? Would have bad internet there.
You can buy an island for like $200,000.
Well, I mean, depends on where the island is. Well, I like lizards.
I thought you'd have to sell.
I have to sell the island. No
Off
lizards.
the coast of England. Up
Oh.
the UK.
It's got to be a pretty small island with really sharp rocks around it, so you can't really get a boat up there. So, and whoever's selling it probably doesn't really have real property rights to it. That's my island.
Buy an island and then use that robot.
It's one of those Somali pirates.
Like when people buy stars, I always wonder how many other people own the same star.
Oh, yeah, that would be a good scam, right? There's plenty of stars up there. You got to be able to see them, but yeah.
Or buy like part of the moon.
Somebody's selling the moon?
Yeah. I think it's funny that there are people who like claim portions of our solar system and tried to sell like asteroids and stuff for mining purposes. They've like set up their own company and they laid claims to all of this stuff.
Well, I mean, isn't that the way it kind of worked to begin with? Isn't that kind of interesting? Like, you had this planet, and then somebody just walked around and said, okay, well, nobody's living here, so I'm just going to set up camp.
So
All of a sudden, it's their land.
the biggest problem with it though is there's a UN resolution that no country on Earth is allowed to claim anything in our solar system as like their own. So
Well, that's what the UN says.
yeah,
So,
I think there have even been court cases over who actually owns and stuff like that.
yeah, but what is the International Fleet? Is that what they're called? What are they called? In the sci-fi movies, what's the space Congress called? It's stuff. No, it's not the United Nations. It's something more important.
Yeah.
They say it's fine.
Oh no, but you can buy. It's $20 an acre to buy land on the moon.
I might do that just to say I'm a moon landowner.
Could be.
Huh?
Could be.
You know what they say? Always invest in real estate.
Well, I mean, but they say that for the rationale that God's not making any more. Well, now if you start going out to this vast solar system, it's too much real estate to go around. It's going to plummet the value of it. It's worthless. I mean, that's why some of these cryptocurrencies have such high values, because there's a finite number of them. Or if you have $100 in your pocket and the government prints, let's say you have $1 in your pocket, and the government's only ever printed out $100. You have 1% of all the wealth. Well, now if the government prints out another $100, you did nothing different. Now you only have 0.5% of the wealth. No difference. Just because somebody decided to print more money. That's bad, right? So that's why the cryptocurrencies are going up so much, because they're a finite amount. They're not making more. Well, they're still making them, but we know how many there will be. But they're bad for people, because then when you get scammed, there's nobody to yell at. So if you buy something with PayPal and you get scammed, then you call PayPal up and you complain. With Bitcoin, there's nobody to complain to. I just told that story.
You can also buy land on Venus and Mars.
Man, that'd be awesome. Huh? Well, once we have some suits that can really deal with the acidic atmosphere and the heat Venus is hot.
Yeah.
It's not safe to go there. But once we have suits and ships that can go there, that might be prime real estate. People go to warm climates here. Gonna build like a bubble thing in Venus and just make it like beach acid water stuff. It's good. All right. So let's see. We finished fixing the plus. We did this last time.
Did we do? I don't think we did.
I don't think we finished.
We didn't finish plus?
Oh, we got like sidetracked and do something else.
You finished that you could check whether or not they're
Oh, yeah. Yeah, that's right. We have our artwork. Here's our artwork. That's right. So here's our ability to detect whether something is currently bound. Because what we would do is, if we're going to do plus plus, we need to make sure it's a bound variable. We could always assume it's bound initially if we wanted to. But we need to make sure it's a bound variable. Then we need to go and find that variable and update the variable in its scope. So this is what we were writing last time. We just kind of rounded it off. So ability to update the most local version of a variable in our scope stack. So presumably we would call this guy after we already are confident that we have a variable or have a binding. And so now we need to figure out which scope has that guy in it. So we need to have an additional ability. So we're going to say ability to update a pair within a scope producing an updated scope. All right, so this guy is going to, presumably we would call this guy once we know here's the scope that contains the binding. So for like something like A. If we want A to be 1 greater than it used to be, if A is currently 3, we want to update the value of A to be 4. That's the idea here. So the assumption we'd be making here, so define update pair in scope is going to be a lambda that takes in a var name and takes in a new value. And presumably we know that that var name is found in the current scope. All right. So what we're going to be producing here is a new scope that is a copy of the current scope with that particular pair updated within it, right? Okay, so remember, our scopes look like they're a list that contains the word scope followed by, it's a flat list of name value pairs, or is it a collection of name value pairs? A list of name value pairs. Let me just run this real quick and we will see. Whatever. Oh, this is the thing we're currently running. Ay, ay, ay. Here, can we come down to our scope? Yeah, it looks like we have a list of 2 lists for our scope. So the catter of our scope is a list of pairs. All right, so go ahead and put this guy back in here. All right, so update pair in scope. Well, we know we're going to be creating we'll probably go ahead and do this as a let. Now, so that should be an interesting thing. Or I'll ask it out loud. So I have a list. I'll give you an example of what this guy looks like. So we have something that might look like this. Scope list A5, B6. And we want to turn this, let's assume we're updating A to B6. We want this to become scope A6, B6. That's what we want this update pair and scope to produce an updated scope. How would you pull this off? Anybody have a fun solution? Could we pull it off using map? Let's say we have a list that looks just like this, taken in small pieces. And I want to produce the list that looks like that.
Updates the value with the var name speed.
The var name we're looking for is, yeah, and updates that pair, right? So produces a new pair. Otherwise, just produces the pair that it was already was, right? So we would have something like a lambda that's going to, I mean, in this case, we wouldn't even need to take any parameters because we already have the var name and the new value. So this could be a function that actually we do need a parameter because we need the pair. This is going to be the pair this guy's going to take in, and it's going to ask the question if EQV car of pair is our var name, then create a list out of car of pair and new value. Else, just boil down to pair. So this is going to be a lambda that takes in a pair, checks to see if the variable name in that pair is the variable we're searching for. If it is, it's going to return a new list with that variable name and the updated value. Otherwise, it's just going to return the pair as is. So this is going to be our lambda, and we're going to put that, now we're going to need to map that across all of our pairs. So I'm going to steal that here. And we're going to create a let. And the let is going to have two variables in it. Let's call this first one a scope ID. And this is going to be update pair in scope needs to take in a scope as a parameter as well. So we need the scope, we need the variable name, and we need the new value. So the scope ID will be the car of our scope. So that's going to be like just the word scope. But we'll write it generically like this just in case we decide to redefine the way our scopes work. So that's our scope ID. And then we're going to have our map func. And map func is going to be this guy. It's going to be the function that when that takes a single pair as a parameter and asks the question associated with that pair whether or not the first element of it is the variable name we're searching for. If it is, it creates a new toList. Otherwise, it just boils down to the original toList. So that's our let environment. Now the let body is going to create a list out of scope ID and whatever map returns for the function, which is going to be our map func, mapped across the catter. And actually, hey, if you want to be fun about this. So that's our map func. We'll give ourselves a third variable. This is going to be our list of pairs, which is going to be the catter of our scope. Like that. So we'll map our map func across our list of pairs. So ultimately, update pair and scope is going to give us a brand new scope. The first element of that scope will be whatever the scope ID is, which is our, whatever word we used for our scopes. In this case, it's just the word scope. But rather than hard-coded in here, we're just going to keep the word whatever was passed to us, just in case we change how we represent our scopes later. And then the second element is going to be a list of pairs. And it's going to be the list of pairs that results by calling map, mapping this function, mapfunc, across all of the list of pairs that are in our current scopes list of pairs. And that mapfunc takes in a single pair and says, if I'm looking at the correct variable in this pair, boil down to a list that has that variable name, but the updated value that came in here. We could have also replaced car of pair with var name. Probably a toss-up, which is faster to execute car or to resolve a variable. Who knows? But they're synonyms. So that's what we do if we found the var we're replacing. Otherwise, just spit out the pair, unchanged. So map always produces a list, right? So this is going to produce for us a list of pairs that has been modified by this map func. And that'll be our second element in our list following our scope. Make sense? All right, so that's update pair in scope. Now, do we have a has binding in scope?
Just in scope stack.
Yeah, so scope stack will tell us whether or not a scope actually, a variable is defined anywhere in our environment. If I only want to update it in a very specific scope, then I need to be able to tell, is this the scope that has my binding? Correct? So let's write a function that gives us the ability to detect a binding within a single scope. Okay, so again, I have something that looks like this. And if I pass in an A, it should return true. If I pass in a B, it should return true. If I pass in a C, it should return false. That variable is not found in there. Huh?
You know what artwork does?
Which one? Artwork?
Yeah, that's what it does. It looks for to see whether a variable has a binding in scope.
All right, but I thought that's what this has binding at scope stack, or is there a second one that we wrote last time?
Your artwork was for scope.
Yeah,
Add pair to local scope.
no below that.
No, I saw it. But why do we call it artwork? Because I thought we had decided that we already had it.
I don't know.
Oh, we can use resolve var in scope.
Yeah.
So really, we do need to write this, but we could write it in a shorter way here. So we'll do define has binding in scope. This guy will be a lambda that takes in a scope stack, or a scope, sorry, and a var name. And this guy will return EQV
Resolve var and scope. Or scope.
resolve var in scope, passing it the scope and the var name. And we want to compare that to false. So this guy should return true if it's found. And if it's found, it's going to give us something other than false. So this gave us a 5. Is 5 equivalent to false?
It should be not.
Yeah, it should be not. This should be the same thing. So I'm looking for A, and A boils down to 5. Is 5 equal to false? No, so it's going to return false. It should return a true. It should be not. And this should be the same thing. Because we're, again, returning the not of what's in the scope stack. So now we can ask, does something have a binding in the scope, specifically? Okay, and this is a predicate, right? It's a predicate. All right, so now we can come down here to update scope stack. And a scope stack is a list whose first element is the word scope stack, and then it's followed by a whole bunch of scopes. Not a list of scopes, but a whole bunch of scopes, flat, right? So the cooter of that is a list of scopes. All right, so this guy, we could do this pretty similarly to what we did up above. So we can create a let and have this guy taking a scope stack ID. And scope stack ID is going to be the car of our, and this guy should take in a scope stack as a parameter, not just a var name and a new value. Bixby was hard at work dictating what I must have triggered it. So I was just filling up the screen with my words. All right, so lambda scope stack var name new value. We're going to let scope stack ID be the car of scope stack. Okay, so again, that's going to be like it'll be the word scope stack, presumably. All right, next value is going to be our map function, or we can have our list of scopes, doesn't matter. So we'll say list of scopes, and this is going to be the cooter of scope stack. And that should produce for us a list of scopes, right? All right, and then the last thing is the map function that we would apply to each scope. And if that scope has a binding, then we would update that scope with the new value. Now, what's the problem with doing it that way? So I have a list of 3 scopes, and I'm trying to say plus plus A. Now in Java, if you say plus plus A, which variable updates? The most local copy of A, right? So if I map a map func across my list of scopes, and I say any of these scopes that has a variable in it that is any of these scopes that has a variable in it that or has a scope in it that has a binding for the variable I'm updating, update it. That's not going to be correct, because if I have 2 A's, I only want the most local one, the most local scope to actually update. The rest of them should remain the same. So how would you write this? Map is maybe not the best choice. Map would be great if I had to apply it to all of them. Update any scope that has a scope that has that binding. But I only want to update the first scope that has that binding. So how would you do that? So I have a list of scopes. And the most local scope is the car of that list of scopes. Correct? And I only want to update that most local binding. And maybe I want to produce a list of scopes. So if I have something that looks like, steal just this piece. So let's say I have something that looks like this. I need one more. Something like that. So here's my two scopes. So that means my list of scopes is going to look like that. It's my list containing two scopes. So if that's the case, I want to produce, if I'm updating A with a new value, and let's say it's for the increment, I want to produce a scope stack that ultimately, well, I want to produce a scope that looks like this. A is 6, but the second A does not update. Only the most local definition of it updates. So I need a function that takes something like this and only updates the most local version of that. How would you do that? Go ahead.
Would it just be like a simple if statement if like the car has the binding, do that. If not, call it again with the cutter.
But kind of just cons the car on as we go. So this is right back to our kind of our early days patterns, right? So we're going to ask the question now, do you want to do this as a helper or do you want to do this as a side function, or maybe do both? Do it as a side function first, then suck it into a helper? So we can do, we can just say define helper to be a lambda that takes in a list of scopes. And this guy is going to ask the question if we have what has binding in scope. We have that predicate that takes a scope and a variable name. So this guy also needs to take in scope, var name, and var value. He's going to need all three of those. And we're going to say if has binding in scope, the scope is going to be the car of list of scopes. And the variable we're checking for is the variable name. So if that boils down to true, then we want to, well, we're going to be done here. And what are we going to do? We're going to just return the, well, we're going to be consing stuff onto a list. So we need to cons onto this the update function we just wrote that updates a var name, var value pair in a specific scope. So what do we call that guy? Update pair in scope. So we'll cons whatever update pair in scope returns, passing it the car of list of scopes, because that's the scope that we found the binding in. That's our most local scope. Then we'll pass it the var name and the var value. So we're going to update the pair in the car of that list of scopes. So this is going to boil down to an updated scope. And we want to cons that onto the cdr of list of scopes. Unchanged. Because we've replaced, we know we have a binding in the very first scope, our most local scope. Therefore, update it in that guy, return the list of scopes with only the most local version updated. Otherwise, what are we going to do? We're going to cons the car of list of scopes. That's our most local scope that we did not find the binding in. We're going to cons that onto our helper, passing it our cdr of our list of scopes. The same var name, the same var value. So if the most local scope I'm looking at it has my variable name, cons the updated version of it onto everything else, not calling anything recursively. Otherwise, if I haven't found it yet, cons the car of my list of scopes, the current scope, which doesn't need any changing, so cons it on as is, onto whatever helper returns on the cdr of list of scopes, so the rest of the scopes, along with the var name and the var value. Make sense? All right, so that's our helper. And now what we can do is we can take this code right here and go up to the lambda and now we can give ourselves a local variable in this let called helper that takes in whose value is this lambda. But now this guy calls helper recursively, which means we have to do what? We need to upgrade the let to a let rec. All right, so there is our let rec that takes in our scope stack ID, our list of scopes, and our helper function. Our helper function is going to take in a list of scopes. In fact, let's see. I think we can do technically right here. We already know about list of scopes. That's this guy right here. We already know about var name. That's this guy right here. We already know about var value, our new value. So here's the var value we passed in. So if we change var value here to new value and change it to new value here as well, it's only two places we used it, then this lambda didn't need to take in any parameters because it already knows about everything it needs to work with. And those aren't, oh, wait, helper still needs the, oh, no, because we need to cut it down. Change it back to that. We do need them because this list of scopes, even though it matches this guy, is actually going to keep getting smaller as we pass in the next list of scopes. I don't think these should conflict with each other because this is the most local definition of list of scopes. So as far as this lambda is concerned, when I say list of scopes in here, I'm talking about this local definition of it, not this more global definition of it. Okay, so this is our helper for this. Takes in a list of scopes of our name and of our value. We find the binding, we'll cons the answer onto it, blah, blah, blah. All right, so then down here, we're going to create a list out of, let's see, it needs to be a flat list, right? So we're going to append scope stack. No, it's cons. Scope stack ID is just a literal. So we'll cons scope stack ID onto whatever helper returns, passing it our list of scopes, passing it our var name, and passing it our new value. So this guy right here is going to return a list of scopes. And I'm going to cons on to that list of scopes, whatever my scope stack ID is. So that'll be the new first element of that list of scopes. So there's our let rec. There's that. There's our update scope stack. So we could take away this helper up here now. So update scope stack takes a scope stack, takes a var name, takes a new value, and should update that scope stack with the updated value. Now something I want to do down here. Let me just get to the error message we had. So change env, this guy. For right now, I'm actually going to, this is our inc expression. Should look something like that. And we update this part as well. Now this should run. Okay. And so for your homework, we have written all the necessary code. We haven't tested it yet, but it should work-ish. So fix inc and dec expression so that they properly increment and decrement. Notice that I put a placeholder here. So I've put temp in here, so you'll need to call the appropriate method for what we're incrementing with the new value. What I used to have there, so you'll see in the previous assignment, what we used to have as a placeholder there, was almost what we wanted because we're always adding one or subtracting one. But now you use the couple of functions that we have above. So we're going to make inc expression and dec expression work in terms of our update scope and scope stack functions. Make sense? All right. I'll put this up on Slack and put the assignment up, and I will see everybody on Wednesday.